Hey everybody, welcome back from Valentine's Day weekend. Hope you had a good one. Okay. Sam Cooke, that's who you hear singing in the background. He's my go-to Valentine's musician. Great voice, sang a lot of great songs, a lot of love songs. So yeah, for the end of Valentine's Day weekend, prepping for tomorrow, for you guys to get this video. That's some Sam Cooke in the background for you, all right? All right, we're doing the CPM 5.3.3. That's the second to last assignment in chapter 5. So we're doing problems 5-91 all the way through. Let's just double check. Yeah, nothing on that page. 5-95. All right, let's see what we got here. First couple problems, we're getting the area of parallelograms. Okay, yeah, so on 5-91, remember to get the area, you need the two lines that end up making a right angle. Okay, so they were nice to you in this first one because they didn't even try to confuse you by telling you how long this side was. All right, they just told you that this line right here is 14, and this bottom down here was 5. All right, so how wide it is and how tall it is. Remember, the area of a parallelogram, I always box it with the shape we're talking about, right? So they call it the base times the height. And again, the height at h kind of looks like that little symbol you make there when you make the right angle. So all you're doing here is 5 times 14. Okay, and it's going to be square meters is your answer. I'm going to let you do that because all you're doing is a little multiplication, right? All right, how about this next one? Now, they tried to fool you a little bit in this next one because, if you noticed, the perpendicular line ended up being a diagonal looking line because they sort of turned it, okay? But again, the two lines you're looking at the two lines that make the right angle. This doesn't make a right angle. That doesn't make a right angle. These two lines. So how tall is it? Is 8 inches. And how wide is it? It's 17 inches. Okay, and you're just going to multiply the two, and it's going to be square inches. It's going to be square meters. All right. And again, I'm going to let you do that. You can come back and check your answer tomorrow. But I think you get this. Okay. Now, triangles. To get the area of a triangle, remember, it is half of a parallelogram. Okay. If I made a clone of that triangle and turn it upside down, put it right here, now I have how wide is it times how tall is it. Okay. And how wide is it? 27 feet. And this is a terrible drawing because they're saying that's 27 and this is only 12. And they look, yeah, this looks smaller, but not that much smaller. Okay. So if I got there this parallelogram, it'd be 27 times 12. But remember, the triangle is half. So the area of a triangle, I'm going to box it in a triangle, is 1/2 of the base times the height. Was meaning math, 1/2 times the base times the height. It'd be 1/2 of 27 times 12. I do half at 12, 6 times 27. You do that in your head. How do you do that in your head? Because it's like 6 quarters plus 6 times 2, right? Again, terrible picture. They're trying to tell you that this is 9 and this is 8.5, which is almost 9, and this is not even close to almost, right? All right, but you know the drill. Now this is a little tougher because you can't take half of 9 or half of 8.5 without getting into some decimals. But you can multiply the 2, then take half of it. You can take half of 9 is 4.5, 4.5 and multiply. Either way, I'm going to let you do the math. This is the formula for triangle. This is the formula for parallelograms. All right, now we get to graph something. Okay, now what am I graphing? 6, 5, 8, -2, -4, -2, -2, 5, So I know I have to go at least 6 over, at least 8 up, but the negative is not far at all. So I'm going to go 5-9-3, make my grid here, okay, and I'm just going to do it like this. Why? Because I need to go pretty far to the right and pretty far up, but not that far in the negative, right? -1, -2, -3. So what do we call it? Remember how we divide this into 4 spots? Okay, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And remember, everything in quadrant 1 is going to be positive, positive. Everything in quadrant 2 is negative first, and then up is positive. Everything in quadrant 3 is negative and then negative. And everything in quadrant 4 is to the right, that's positive, and then down is negative. Okay, just a little remember. And what is this point called again? O is called the origin. That's where you start, where everything originates from. Okay, get that? All right, let's plot these points, 6 and 5. Now, what do I do first? Do I go over first or up first? If you don't know, then write in big cap locks, over and up. Okay, now you can put the arrows going both ways because we're 4 quadrant now. Put a positive going up, negative going down, positive to the right, but negative to the left. Okay, over and up. Over first. So I'm going to go over 6 and up 5. And then over 8, but down 2, -2. 8, -2, 6, 5. Go ahead and write my coordinates. Okay, this is good practice. -4, -2. -4 and -2. And then the last one is -2 and then up 5. And what shape do I make here? Let's check it out. Connect those 2 dots. Connect those 2 dots. It's a horizontal line. So 2 horizontal lines, those are parallel then, right? So 2 lines are parallel, the other 2 are not. That is called a trapezoid, right? Okay. So now what you want to do is you want to find the length of the top base. How far is it from here to here? Okay, I'm going to let you see that. And then I'm going to have you, it says find the distance from the bottom base. Okay, top base, length of the bottom base. Okay, so they said to go ahead and label this. A, B, C, D. And they want you to find CB. Yeah, CB. And then they want you to find AB. How long those are. Okay. And now the distance between the 2 bases. So like from here to here. Okay. I'm going to let you find that. Okay. So this is A. That's B. All right. Now on to factors and multiples. 5-9-4. Okay. Write in big letters. Make that the F really big. Factors fit. Okay. Write in big letters. Especially the caps, the first. Multiples are many. Okay, it's called alliteration. Okay, so factors fit. Okay, the factors of 24 all fit into 24. Okay, but they're telling you the factors of 7 or the multiples of 7. Factors of 7 are just 7 and 1. Nothing else fits into it. The multiples of 7 are 7, 14, 21, 28, right? What are the first 6 multiples of 9, sorry. Well, it's 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, right? That's the first 6 multiples of 9. Okay, you're going to find the first 6 multiples of 12. Okay, and then you're going to find the least common multiple of 9 and 12. So you're going to find the smallest number that is a common multiple, right? And then on D, I'm going to go ahead and write LCM, that's the least common multiple. And on D, you're going to find the greatest common factor. Okay, so that means you're looking for the greatest number that fits into 9 and 12. Okay, when I find the numbers that fit into 9, I got 1 times 9, 2 won't fit, and 3 times 3, that's it. All the factors of 9 are 1, 3, and 9. Okay, now you're going to find the factors of 12. I found 2 of them for you. Okay, see what fits into there, and then find the biggest one that fits into both. Okay, all right. Hopefully you remember how that works. Otherwise, you'll get a good review. Right? If you don't, that's good that they asked this question. All right, I'm going to turn Sam Cooke off so we can finish this up. Otherwise, it's hard for me to concentrate. I want to start singing, Sam. Yeah, his songs are really great songs. I always want to start singing, and you don't want that, right? I have to make you promise you don't tell my wife on me for singing to you again, right? And she's right over there, a little upside down now. Upside down. She's doing her Google Classroom work too. We're a pair today at the Taylor Mountain too. Fun. All right, 5-95. What are we doing here? We're drawing a number line, and then we're going to draw and label a dot to show the position of each of these numbers. So A, we got 2.5. B, we got 1/2. C, -2. D, 0.5. E, -1 and 1/2. And F, -3/4. So when I draw this number line, I put 0 in the middle. Okay, the biggest number to the right is positive. That's the only one that's bigger than 1, huh? 2.5. So I'm going to divide these up into 4. So that's 1, 1, 2, 3, 4. 1, 2, 3, 4. That's 2. 2, 3, 4. That's 3. 2, 3, 4. That's -1. -2. -3. Okay. Now, I'm going to leave it up to you how you want to do this. Because these fractions are so common, I mean, halves and fourths, right? And the decimals are so common, all you got is 0.5s. I'm going to let you figure out if you want to do anything special with these before you put them on there, or just put them on there. Okay? All right, good luck with this. I don't think this one's going to be too hard for you. Have a good one. Have a great Tuesday. Remember, it's the only day named after a number. That's why teachers love it so much. And we will see you soon.